Rightio. Well, I'm going to start talking about congruence and specifically triangles that are congruent. Um, and so I'm going to finish up something on the last set of notes and then go on to this new set, which has a lot of writing on it. But once we get practicing, it's really not too bad. And apparently I forgot to delete a bunch of stuff, so you get to see me do that. It'll be really exciting. Look at this. Delete, 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 delete. Delete, delete. Oh. Boom. Okay. So, a congruent statement. That's what we need to talk about now. And it's pretty simple. It's basically when you have two sets of triangles and we want to say that they are, how do we say that they're congruent? You know, a lot of people would just say, oh, triangle ABC is congruent to triangle DEF. And that is not true. What really happens, so you write the little triangle sign, ABC, congruent, which is an equal sign with this little tilde above it, FDE. And the reason being is that you have to keep everything in the exact same right order. So if you look at angle A, it's between one tick mark and 3 tick marks. So that means we have to look for the one over here that's between 1 tick mark and 3 tick marks and put it first, A and F. Okay, B is between 1 and 2 tick marks, so we look for 1 and 2, that's D, and then C and E. So we have to keep everything, all the angles, all the sides in the exact same order. Because in a congruent statement, you should be able to look and tell what's the same without even seeing the triangles. So looking at this congruent statement, I know that angle A is the same as angle F, B is the same as D, C is congruent to E. I also should be able to tell that line AB is congruent to line FD because it's the same order, same letters. Or line CA is congruent to line EF because of the order, right? So CA, 3 tick marks, EF, 3 tick marks. So when you're doing a congruent statement, you're really just putting it in the right order and then trying to figure out what's true. So AB is congruent to DF, as we said. I mean, you can see that from the picture because of the tick marks. But like I said before, you should be able to tell that without the tick marks. And angle B, the middle one, is congruent to angle D, which is the middle one. And that's that. There was just a jump because I paused it, so I had to go do something. So angle E, if you just looked at this, I mean, it's the last letter, so it's congruent to C. Okay, so, and once again, AC, first and last letter, congruent to FE, first and last letter. And you could have done it just by looking at the picture and the tick marks, but the point of a congruent statement is you don't have to do that. These ones are usually easier when I give you the angles, so just so you know, hopefully you remembered on this one too. 1 tick mark means the ones with 1 tick marks are the same, the double tick marks are the same, and the triple tick marks are the same. These are kind of the same thing. 1 arc means those are congruent, 2 arcs means those two are congruent, and 3 arcs means those ones are congruent. So X, Y, Z is congruent to R, S, T, because we're just matching up the tick marks basically. And that is that. Okay, so that's how to write a congruent statement. I'm at 3 minutes. Okay, now we got to talk about congruent triangles. And this is a little more wordy. The first thing is there's a word that is not as important this year just because we're not doing everything we normally do. But it's important. When two triangles are congruent, their parts are congruent. So if I have two different triangles that I say they're the same, then they each have a part, a matching pair of like angles or sides are the same. And this has a name. There's a rule for this. It's called CPCTC. And normally you'd have to really memorize this word, but you're lucky that this year, less important. And its corresponding parts of congruent triangles are congruent. You know, but who knows, maybe if next quarter things change and we go back to a more normal pace, you might have to know this. But it's also just fun to say CPCTC. So, we have two triangles, SHELDO. And if triangle SHE is congruent to LDO, and we talked about this just a second ago. We know angle S should be congruent to angle L because they're both the first letter. So just as a quick review, SE is the first and last, so it's LO. Okay. So for two triangles to be congruent, all three angles and all three corresponding sides are congruent. So if I wanted to show that two triangles are congruent, that's 6 different things we'd have to check. 3 angles, 3 different sides, and trying to make sure they're all the same. So there are shortcuts, and these only work with triangles. First one's what's called SSS, which stands for side, side, side. And what's that saying? If all the sides of a triangle are congruent to the corresponding sides of another, then they are congruent. Meaning that if I have two triangles and I know all the sides are the same, you don't have to check the angles, you only have to see the sides. So if I know this is 4, 10, and 7, and this one's 4, 10, and 7, you can say they're congruent by side, side, side. We don't have to check the angles. But the nice thing about it now is that now that we know they're the same, we know those angles are the same as well. So we automatically know now that this and this are congruent because SSS told us that these are congruent triangles. So we know now that those two are congruent. My tick marks are terrible. And we know that these angles are congruent. So we just know that automatically, which is the nice thing. We don't have to check them, we know it. So there's another one that's called SAS, which, if you can guess, will be side angle side. And what side angle side means is that if two sides in the included angle, so the angle between them, and this is very important, those angles has to be between them, of one triangle are congruent to two sides in the included angle of another, then they are congruent. So what these ones look like is we have a tick mark, an angle, and a tick mark. And then the same on this one. And the reason, and I tried to erase it, but didn't really turn out very well, is that I usually highlight when I'm looking for things like this. We're checking for basically, are these things the same and are they in the order of side angle side? So I saw a tick mark here, right? And that's why I wrote S. And then I said, oh look, there's an angle right here that's between them. That's an A. Those two angles are the same. And this is another side that's the same. And that's a side. So now we know that these are congruent by side angle side because there's a side, corresponding sides, corresponding angle, corresponding sides that are congruent. Oh gosh, having that there is annoying me. Why? Anyway, by side angle side. And then we have another one which is ASA, which I'm sure you've got the pattern now, stands for angle side angle. So if two angles in the included side of one triangle are congruent to two angles in the included side of another, then they are congruent. So this is kind of the opposite of what we just did. We have two angles that are the same, and then the side between them are congruent, so we could say they are congruent. And I say no ass here because angle side side does not work. Will never work. So if you label things and it says angle side side, then you can't say they're congruent, and you say what's called CBP, can't be proven. Okay, so this is the first part, and then there's another part that I will put in the next set of notes because there's more than just SSS, SAS, and ASA.